been swimming in the summer and had to get out because it was lightning? I bet you're probably wondering why this happens. This is because of a process called electrolysis. Electrolysis is the use of electrical energy to bring about a chemical change. As you can see in this comic, the water molecules have split apart into the two H and one O ions. If lightning had hit the pool, it would have split the water into these ions and an electrical current would have been passed through it. That could have electrocuted you. Electrolysis can be used in many things. It pertains to molten salts, aqueous solutions, and electroplating. A brief history of electrolysis.
Michael Faraday discovered the laws of electrolysis. He also created the terms cation, anion, electrode, and electrolyte. He is known for many other discoveries as well. People say that if Michael Faraday had lived today, he would have received at least 6 Nobel Prizes.
Now we will discuss electrolysis pertaining to molten salts. Molten salts can be contained in an electrolysis cell. In this cell, chemical reactions occur at 2 electrodes, the cathode and the anode. Reduction occurs at the negatively charged cathode, and oxidation occurs at the positively charged anode. NaCl can be used as an example of electrolysis in molten salts. NaCl melts at about 800 degrees Celsius. At this temperature, Na positive and Cl minus ions are freed from their rigid lattice structure. This allows electrolysis to occur. A potential is applied and the Na positive ion is attracted to the negative electrode, and the Cl negative to the positive. Then chemical reactions occur at each electrode. The cathode reduction is 2 Na positive plus 2 electrons yields 2 Na. The anode oxidation is 2 Cl minus yields Cl2 plus 2 electrons. This net ionic equation is 2 Na plus 2 Cl minus yields 2 Na plus Cl2. Electrons move through the electrical circuit under the force exerted by the applied potential. It is important to note that the reaction is not spontaneous. The energy is provided by an electrical current. In summary, molten salt electrolysis consists of a positive ion being attracted to the negative electrode, the cathode, and a reduction reaction occurring. A negative ion is attracted to the positive electrode, the anode, and an oxidation reaction occurs there. Here's a picture of the NaCl molten salt electrolysis. As you can see, the positively charged sodium ion moves to the cathode, where it is reduced to a sodium metal, and the negative chloride ion migrates to the anode, where it is oxidized to chlorine. There is also a battery connected to this, which provides the voltage or the potential energy needed to perform this reaction.
Electrolysis in aqueous solutions are similar to molten salts, but are more complicated because now water is involved. Water is an electroactive substance that can be oxidized or reduced in an electrochemical process. In electrolysis, the molecules split into a positive anode and a negative cathode. The positive anode is formed from an oxidation reaction, and the negative cathode is formed from a reduction. If you consider the electrolysis of aqueous sodium iodide, the electrolysis cell contains Na+, I-, and H2O molecules. In the cathode, the sodium ion is a spectator, and the H2 and OH- are formed. And at the anode, iodine is formed, and O2 and H+ are spectator ions.
Electroplating is the process of coating a metal object with a thin layer of another metal by means of electrolysis. In electrolysis, the cathode is a metal. The cathode becomes completely covered by metal if the cathode is immersed in the electrolyte. Electroplating is used to improve the appearance or protect a metal object from corrosion or rust.
The process of electroplating.
The entire container is called the electrolytic cell. It is filled with a solution of a salts of a metal or a metal bar that is to form the coating, which is called the electrolytic bath, and the object that is to be coated. Next, the object to be coated, which in this case is the spoon, is connected to the negative side of the battery, and the silver bar, which will be used for the coating, is connected to the positive side of the battery. Then, when electric power is supplied by the battery, electrolysis begins. The coating, which is given off by the silver metal bar, forms an alloy and adheres to the cathode. So the silver coating will remain on the cathode, the spoon, after it is removed from the bath. Then the metal bar will dissolve in the bath at the same rate that the bath gives up its metal to the cathode. The longer the process continues, the greater the thickness of the coating on the cathode.
The equipment for electrolysis are a director current energy source, an electrolytic cell, 2 electrodes, and an electrolyte. A common arrangement, as pictured on the bottom, consists of a battery, the source of the current, where 2 poles are attached to 2 strips of metal, the electrodes, which are immersed in water with a few drops of acid added to them, which would be the electrolyte. Real-life applications. First is preparing the elements. Electrolysis is used to break down compounds that are very stable. For example, aluminum is a very important metal in modern society. But the main natural source of aluminum, which is aluminum oxide, is a very stable compound. A compound that is stable is difficult to break apart. You can't get aluminum out of aluminum oxide just by heating the compound. You need more energy than heat can provide. Aluminum is prepared by electrolysis. Once melted, aluminum oxide forms ions of aluminum and oxygen. Pure aluminum metal is obtained at the cathode, while oxygen gas bubbles off at the anode. Sodium, chloride, and magnesium are 3 other elements which use this process. Next is the refining of copper. Electrolysis can be used for purposes other than preparing elements. One example is refining of copper. Very pure copper is often needed to make electrical equipment. An electrolytic cell for refining copper contains very pure copper at the cathode, impure copper at the anode, and the copper sulfate at the electrolyte. When the anode and cathode are connected to a battery, electrons flow into the cathode, where they combine with copper ion in the electrolyte, and pure copper is formed on the cathode. The last real-life example of electrolysis is electroplating. Another important use of electrolytic cells is this process of silver, gold, chromium, and nickel. This process was discussed earlier in our presentation. Some examples of electroplating are shown here, with jewelry, wheels, and steel bumpers. We know all of these terms relating to electrolysis can be confusing, so here are some terms to note. First, the anode. The anode is the electrode in an electrolytic cell through which electrons move from the electrolyte to the battery. The cathode is the electrode in an electrolytic cell through which the electrons move from the battery to the electrolyte. The electrolyte is any substance that, when dissolved in water, conducts an electric current. The ion is any particle, such as an atom or a molecule, that carries an electric charge. Electroplating is a process that uses an electrolytic cell to deposit a thin layer of metal on some kind of surface. And lastly, as used in all of the definitions, the electrolytic cell, a system in which electrical energy is used to bring about chemical changes. We hope you enjoyed our presentation, and it is our hope that you know a lot more about electrolysis cells.